Hello, my name is Dan Oak, and I'm a student at Athabasca University, currently taking the course Comp 444, Embedded/Robotic Programming. And if you've been following the videos that I've been posting to the course forum so far, you'll know that I'm going through the SparkFun Inventors Kit Guide and showing you how I've completed some of the projects in the guide, along with the associated coding challenges. However, today's video is going to be a little different. I'm not going to be going through any code or the coding challenges. I'm just going to show you a demo of Circuit 5C, which is the last circuit in the last project of the SparkFun Inventors Guide. So if you've made it this far, great job. So I haven't made any modifications to the code, really. And when I say really, the motor driver that comes with the SparkFun Inventors Kit and the course is a better, more efficient motor driver than what I'm using today. I'm using a L296N motor driver. I'll pull off the hood in a little bit and show you, but as well as I'm using, different components that didn't come in the kit, but they're all essentially the same. The same type of motors and geared motors and wheels, and same type of ultrasonic sensor. I just bought some extra stuff on Amazon so I could do something. Obviously, you'll also notice that I'm not using the SparkFun Inventors Kit base plate with breadboard and SparkFun Redboard Arduino microcontroller. Instead, I'm using this sandwich container, which has, again, I'll show you under the hood after, which has all of the components inside. But beyond making a couple tweaks to the code, which were just really naming choices for the PWMA and inputs for the motor driver, I've done nothing besides upload the code to the circuit, and we're going to see if it works. So theoretically, if it works, it should go to the walls, and before hitting the walls, it should stop and turn around. Now, I am anticipating a couple issues before we even get going. One of the issues I'm anticipating is I've only got one of these ultrasonic sensors. So, and if I was using the base plate that came with the SparkFun Inventors Kit, it's only about this wide. So, and the wheels are, attached to it underneath. So it doesn't have a very wide base, meaning the ultrasonic sensor is essentially going to be able to scan, because it has about a 15-degree scanning radius, is going to cover the entire width of the vehicle. In this case, I've got this tiny little, ultrasonic sensor that's meant to cover the width of this entire sandwich container, plus the wheels are sticking out quite a bit the way I've designed this. So we know it's not going to fully work because it's only going to see what's in front of it at a 15-degree radius, meaning if anything's over here, we're going to miss it, and the tire's going to hit. Same with on this side. So I do anticipate that. How would I solve that? Well, I would get a couple more ultrasonic sensors, put one here and one here, so I'd have a middle, a left and right and middle sensor, and the coding would have to be a little different. Basically, if there's something directly in front, we just stop, and if something is detected on, let's face it this way, if something was detected on the left sensor, well, we would turn right. If something was detected on the right sensor, we would turn left, and so forth. And maybe that's something I'll do in a future iteration of this. Mount 3 ultrasonic sensors, kind of one at an angle and one here at an angle. And again, the coding will just be based on what sensor is doing the reading. Again, if the middle sensor is doing the reading, we'll just stop. If the left sensor is doing reading, detecting an object here, we would turn right. And conversely, if the right sensor was detecting something, we would turn left. So that's one of the issues. Also, it's fairly dark in here. There is light in the ground, but there's like some dark shadowing. And when I was doing research on the ultrasonic sensors or LiDAR, or any of the the technology used here, it seems the darker the area is worse, but that's more or less for LiDAR, so that shouldn't really come into play too much. But we'll see. Anyway, this is the maiden voyage, so we'll see if we crash and burn. Let's test it together. Oh, and before I get started, I'm also anticipating some issues over here because I've kind of created barriers as walls, but over here, the ultrasonic sensor is at such an angle that it's kind of, if you see it, kind of angled somewhat up. So it might actually miss seeing anything here at the pillow. Now, I've done that on purpose to see if it does catch it or not. And if it doesn't, it's most likely just going to ram into the pillow, but it's soft, so I'm not too concerned. Anyway, without further ado, let's turn on the little guy here. So as we can see, the width is already coming into play, where it's only able to sense directly what's in front of it. But since the okay, we'll do a quick shut off of this. I'll just put this back on. I just put the batteries back on and obviously didn't close this very well. Okay, so already off the bat though, we're seeing some issues. We're seeing the width come into play. So if it comes straight on, it seems to work. But if there's any angle, like at any of the angles here, it senses nothing in front of it, so it keeps going straight, but then it hits the side. Obviously it did hit here because the angle that shot up is not enough, so I'm going to try to make that up and see if it doesn't hit this time. Well, let's try it again. So yeah, if it comes straight on with the thing, if it comes straight on, it does pretty good. But if it comes at a big angle, it's not going to work. So see, yeah, if it's straight on, you've got a decent shot of stopping. Although I do have it at full speed, so we might want to give it more time to actually register, and then the slower, they'd be more likely to catch it. But yeah, so it seems as anticipated. The width is coming into play, so I would need either to make it shorter there. Let me just stop this guy for a second. So you can see when it came straight on, it stops. But I've got this at full speed. Like I said, there's no modification of the code in the sense of any of the logic. So it is going at full speed. But when it gets here, it gets really close before it turns around. So it gets really close, but it did stop when it's straight on, so it did work. But if it comes at any sort of angle, like I said, it's only sensing, and I don't know what the sensing distance is either. I didn't really look at the code because I haven't done the coding challenge yet. I just uploaded their code. But it might be too close that it's waiting till here, in which case it's guaranteed to hit this side. So maybe increasing the distance will help alleviate the width issue. But like I said, I do need to, having this about the width of the battery compartment, which is the width of the SparkFun, base plate with breadboard and Arduino all in one. It'll probably, and the wheels are underneath, so there's no extra width by the wheels. It would probably work perfect, so I'll try that after, as intended by the course. But even if I wanted to fix this, I could just slow down the motor a little bit, or I could increase the distance at which it turns so it doesn't get as close. But the ideal solution would actually just be to increase the amount of sensing I'm doing. Instead of just having a middle sensor, increase one on each side. So again, like when we read the course textbook that comes with COM 444, the original kind of autonomous robots like this would have, a full ring, concentric ring of ultrasonic sensors, so they could sense all around. So I wouldn't necessarily do that. I don't have that many ultrasonic sensors, but I could definitely add one more as a left and right sensor that would detect and help with this. Again, the unfortunate thing, and I've done this on purpose where I have some things open, where if it's coming straight here, it's just going to ram into that full speed because it's actually not necessarily going to get the detection angles about 15 degrees on either side, but depending on the speed and when the detection actually turns it around, this might just smash into that. But yeah, let's try it again. So again, if we go straight on with this, we should stop and work. So that's when it works the best, when it's straight on. Let's try. And that didn't work at all because it happened to go straight for that little center based on the friction of the wheel. So let's try again. What are you doing, buddy? So yeah, that was a straight on one, and it worked pretty good. Anyway, that's enough. Thanks for watching, and I'll see you next time. This is what my kids do sometimes with our vacuum, our Roomba. Just kind of, when they don't want it to go in an area, they just do this with their feet. And sign is out.